What's crack-a-lackin'? Wages World coming at you with another video. Let's get into it. Got you over here at NOAA Space Weather Prediction. And what you're looking at there, R1. R1. R1 radio blackout conditions. We've had some more M-class flares. Multiple ones. And also we've had some CMEs get shot off with some of these. As you can see there, look at those. A bunch of them. Check them out. I mean, the sun's just flaring all over the place. Okay? It truly is. Actually, we just had a flare as I'm making this video, and I'm showing it to you right there. Now, what's this mean? Well, we're under a geomagnetic storm watch, okay? I do think it's probably going to turn into like a geomagnetic storm warning. What all that means is, yeah, we're going to have a geomagnetic storm, or we're having those conditions. Again, like a severe thunderstorm warning system. But as I scroll down through here, guys, what you're going to see is we're going to take a look at the sun here. These are the sunspots. Okay, especially these ones right here in the middle. The ones here in the middle are definitely firing off. But the whole sun itself is actually very, very active right now. All the sunspots on this side are acting. They're flaring. They're being very, very active. So, especially when they're facing us, like that one is. And the one down there on the bottom left is actually facing us pretty much straight forward too. And they're both producing flares with CMEs. So that's one thing we pay attention to. We know there's a difference between a flare and a CME. So as long as we know that, we can look at the proper data and look at what we're looking at here. We can get a better idea of what's going to be happening. I can't tell you exactly how strong these things are going to get this time. There's so many of them, and it's making it really, really hard to forecast because they can bump into one another. They can become what they call the cannibal CMEs. They get steered, pulled this way, that way. The polarity of it, the BZ guys, like I said, big time. That really does affect how strong things are. So, yeah. Guys, I got you over to Discover, and what you're looking at there is the BZ. You know, that's what I talk about with the -6, the red line. Right now, guys, that's an interesting signature. It's kind of a swooping thing. Not sure if I've ever seen that before exactly that way. But -6 is what we look for. It shows up in purple. And what that is when it is showing up in purple, it means things are coming in a lot easier. And, you know, that means that we can get into stronger storming. Again, we got all this stuff coming. Now, look there at the density. Like I just showed you on the Magnetosphere tool. Density is extremely low. It looks like it's jumping around a lot, but it's not, guys. That's a 1, okay, on the 1 unit. The chart there isn't going 0 to 100. It's only going 0 to 10. So just wanted to point that out. And as you got here, you got the speed. Yeah, it's kind of slow too. I just showed you that too over on the Magnetosphere tool. So, but I did want to point that out, guys. And, it's going to be one of those things we're going to have to watch with all these things coming in. And we're going to look at this data and we're going to keep track of it and see what happens. If things start to move and I think we're going to get into some bigger, stronger storms, I'll pop back on and let you guys know. But these are the things I look at, and I highly encourage you guys to go do so also. Please do this for your own sake. Just go look at it so you don't have to trust what I say. I'm giving you guys the tools to go look at what I'm saying. And research it a little bit yourself if you want to. But you guys can do that. Please do that. You know, I strongly suggest you do that. But anyway, guys, we're going to move on. Okay, guys, I got you with the Magnetosphere tool. This is over at NOAA. This is the newer Magnetosphere movie tool. And this gives us a really good idea of what's going on visually. This model does give us an extremely well visual representation of our magnetosphere as it gets hit by solar wind and CMEs. You know, a lot of times you'll see that bow shock out front, right? That bow looking thing that I've talked about a bunch. Now you can see how we're starting to get hit a little bit here. Now the lighter colors means velocity, or the speed of it, is actually moving fairly slow. You get towards the darker blues or darker reds, that means that it's moving faster. Okay, so right now we're just kind of hanging around in there, and when you look at the density, see how it's all white? That means low density. We're still experiencing some of that flushing effect from the earlier hits we took this week. Okay, this past week. it took a lot of the particles and shot them on out into space. Solar wind, CMEs, those, when they hit us, they grab things like that and it gets pushed right on out. It flushes on out. Okay? So it's not unusual for us to see the density go really low after we take these hits, especially from like a G3 storm like we experienced. With the following G1, I think it actually got to a G2 at one point. But notice, guys, I do want to point out, you can't really see a bow shock. What's a bow shock in the magnetosphere? It's the point where the solar wind meets our magnetic field. The reason why you don't see it a lot of times when you come over here is because all that means is that if this whole thing was white, like low density, or even blue, high density, it just means this model is showing you that the density is the same on both sides of that bow shock. That's all that means. The bow shock doesn't go down. The solar wind would have to go completely away, which means our sun would be gone, or our magnetic field would have to go completely away, which means we would turn into Mars. Okay, so that obviously, yeah. So, magnetic pressure, guys, that's what we're looking at here. It will circle on through, and probably the red part will actually probably engulf us later on this weekend sometime as we start getting hit with these things. And that's what this particular model here is showing you, the pressure. The darker color reds, that's where the more pressure is. So, but anyway, let's move on. Okay, guys, I got you over here at the Geoelectric field model. It's the one that they use for bettering themselves to forecast earthquakes. As you can see here, guys, we're getting a little bit of activity, and this is coming from these initial hits from the coronal holes and from the multiple CMEs that are headed our way. So yeah, this is exactly what we would expect to see. Geomagnetism affects geoelectric, which is the conditions on the surface here. And that's what you're looking at there. So the USGS and NOAA is working together here. That's why they're using this model. And it will help us forecast in the future, because we do know space weather affects earthquakes and seismic activity. Okay? And they're just trying to add more data points now, finding, and they're exploring different theories and everything else. And this is part of that. So, yeah, guys, I got you over at the NASA CME tracker, the end little spiral. As you can see here, guys, we've had that's one of the CMEs. Remember, this is the one that really only shows one at a time. We'll look at the NOAA model here in a minute. But they're saying, this is the side cut there. That's our orbital line stretched out in a straight line. And the top-down view. All three are showing this one to hit. Again, all those factors I talked about before come into play here. So we just got to pay attention and, and look and nowcast, like Ryan Hall likes to call the weather forecast, which I think is awesome. So if anything changes or anything like that, I'll definitely be here to let you guys know that. But as of right now, it's just one. So let me show you the NOAA forecast, where it's showing more than one, and you're going to get a good idea about what I'm talking about here. I got you over at the NOAA one, like I just said. And as you can tell, guys, look, check that out. All right, what this does is it gives us 2 days historic data behind us and tries to forecast 5 days in advance. You guys know I don't trust it 5 days out. Most people don't, because it changes all the time. You see that? That was 2 separate eruptions. There's a third one moving faster right behind it. Yeah, guys, there's a bunch happening right now, and coronal holes. So it's making it really, really difficult to forecast this. And again, let's just pay attention. Again, nowcasting type of thing. The BZ, all the above. Now that's the velocity. You got a top down and the side cut there. Still hitting. Okay. Now these first initial 2 does not look like they're right on the nose, but the one behind it, and there's a bunch more popping off all over the place. So yeah, it's just going to be up in the air for the next 2 or 3 days. Now, we may not even get out of G1 storm conditions. I don't know yet. I don't think really hardly anybody does. Okay? But we're just going to keep an eye on it. And if things start to look like they're going to really ramp up, I'll definitely be on here to tell you guys. But I just thought you guys would like to see that, because that doesn't happen very often. This model showing 3 separate CMEs coming our direction. So yeah. So what is their forecast? What's NOAA's forecast? Well, let's go take a look at it. This is NOAA's forecasting. You got the 24th through the 26th, and right now they're showing a G1 on the 24th. Now, we're going to just pay attention because that's probably going to change. Now, if you see the radiation storm, the S1 there, we got about a 10% chance for the next 3 days, which comes typically from flares. Now, if you look at this, check that out. They're saying a 60% chance of R1, R2 flare. Right? But look below that, R3. What is that? That's the beginning of X flare class geomagnetic storms. We don't often see 15% there. Usually that's at a 1. Okay, so when those start to increase, what that means is that we're seeing sunspots that have the potential to bust off with some X-class flares. And with the X-class flare, gives us a greater chance at a bigger CME. More powerful, faster, higher dense, all the above. Now the flare part of it, again guys, is X-ray, which is what you're looking at the top left there. The solar X-ray, right there, the flux. Okay, so those get here in like 8 minutes. The CMEs typically take between 3 to 5 days to get here. But the bigger ones, like if you're talking X-class flare, typically they're here in 2 days or less. They just move faster as far as the CMEs that are with the X-class flares. But I do think it's interesting. We need to pay attention to the 15% there. The 60 is almost, well, I mean, you can see we've had a bunch of M-class flares. If it breaks that line, I mean, we could sit here and count them. We got 1, 2, 3, 4, 5, 6, 7 in the past 2 days of M-class flares, which brought with them R1 radio blackout conditions wherever the day side of the planet was when those hit. That's why this is important to tell, because ham radio operators use it for communication. First responders do. They use the ham radio for that. A lot of them do anyway. And the flares affect that. So is geomagnetic storming. So it is important at some level there, guys. It's pretty important, actually. You know, what if you had somebody get sick that you loved, and we were having all this stuff going on, and people couldn't understand why they were having problems communicating? Well, if we have a better understanding, maybe we can do more things to kind of get around that. Maybe switch to some sort of other communication while we're having these storms. I don't know what the answer is there, but most certainly we need to pay attention to this. So anyway, guys, let's move on. Guys, let me show you the M-class flares hitting right there. That's the day side of the planet. So wherever you see that, the more intense X-ray signature there, that's where you're going to see the R1 or R2, R3, whatever radio blackout conditions we see. We also see radiation storms on this, and here's the bigger M-class flare getting ready to show up right here. But when we do get radiation, proton increases, this will show up on here too, and you'll see things get flooded. On the north and south pole, everything turns red, and as you can tell there, guys, look at that. So it's just kind of a dead bullseye from a few hours ago on the X-ray flux, which means that's where the flare happened. And that's the part of the planet that was on the day side facing the sun when that flare flashed off. Okay? So, yeah. Guys, I got you over here at SOHO. This is SEED's website, but this is the SOHO Observatory. The satellite always looking at the sun a million miles closer to it than what we are. I put a little bit of a diagram there in the middle. And this is the LASCO C2. It's the more zoomed in version of the Coronagraph. The black disk is always there. It's a physical disk to black out the main light of the sun so we can get a capture at all. Now you're going to see multiple eruptions here, guys. I'm just going to let this thing run so you can see them. And they're fairly significant. We see some halo CMEs. That means that you see a signature all the way around that occulter disk. Okay? That either means it's going away from us or it's coming right at us. And there are a few of them that are coming our direction. So, but I just wanted to show you guys that one because it definitely is, had quite a few eruptions. And it wasn't just that day. Okay? There's quite a few of them. So, I got you over here at SDO. Now, this is the satellite that is in geosynchronistic orbit. okay? It means it stays over the same part of our planet at all times, but it's always looking at the sun. Now here I've rolled it back and forth so you guys can get an idea of all these sunspots flaring and erupting. Okay, this is the 94 angstrom. It's extreme ultraviolet. It's picking up the 94 angstrom part of the light spectrum. That's what we're looking at here. Where you see the flashes, those are the flares. And you can see how the corona gets a little bit disturbed every time that happens. And if it's disturbed enough, guess what? That means that's plasma firing off the sun. Okay, it's not the surface. You're looking at the corona pretty much there. The darker parts you're seeing are the colder parts of the sun, which means the surface. Yes, the surface of the sun is colder than the atmosphere. That's why they sent the PSP out there, the Parker SP probe. Okay? And so, yeah, we got coronal hole stuff coming our direction. We got these CMEs from the flares. We've even got some filaments that erupted. And a lot of this is now on the Earth-facing side. Guys, I mean, look at that. Okay? That's right in the middle. So we do have some things to look at, and if anything changes, gets any kind of worse at all, any kind of data changes, anything more happens, I'll be back on here to give you guys an update. Okay guys, we're going to end with this right here. I got you back over here at the NOAA model, and what you're looking at, guys, you got 1, 2, 3 CMEs right there. But remember, guys, listen, we got coronal hole streams happening also, so we're already going to have increased activity. And if these things do what they possibly can, none of these really look like excessively huge or strong, okay? But sometimes that doesn't matter. You heard me use the word reverberating yesterday or the day before whenever I posted my last video of our magnetosphere. We're still kind of reverberating from the G3 storm we had as we got hit with another storm, right? So if that's happening, our magnetic field might not be in the correct position to really give us the full protection that we need. So all that means, though, is pretty much increased aurora. I guess high latitude, you could see some transformer issues. High latitudes means closer to the poles. Okay, that's all that means. Mid latitude is kind of where the majority of the population of the planet lives. And then you got your equatorial latitudes, which is obviously around the equator for people that like it hot. But anyway, so that's what you're looking at here, guys. Again, guys, I promise you I'll be back here to give you guys an update if anything happens. But look for some more videos and live streams this coming week. I'm going to continue on doing what I'm doing right now, guys. I'm starting to get back into my groove and doing these edited videos and posting them as Premiere or even running them during a live stream. I'm not sure what I'm going to do with this one yet. I think it's working out well. It's keeping me focused. It's keeping me on target. And then when I do the live streams, I'll play these. And then after that part of the video is done, my live stream, then we can move on to some deep explanations, answer questions, shout outs, those kinds of things. So anyway, guys, thanks for being here. God bless. Yahusha saves.